Hello everyone, I'm here to present Paratrace. Let's start with a simple reality. In a multi-chain world where money moves in seconds, but trust still moves slowly, and that gap, that exactly where fraud hides, and that Paratrace exists to close that gap. So let us look at a problem. Today most monitoring systems are still single chain and reactive. But by the time suspicious activity is detected, funds are already taken and split and moved across parachains and are harder to trace. This leads to three major risks. One is chain hopping for laundering, fragmented visibility across ecosystems, delayed alerts that arrive too late. So the real problem isn't just visibility, it's the absence of a real-time actionable risk signal in cross-chain environments. And a solution that we have built, and for before moving to the solution, we'll say why we built this. So our motivation was simple. If liquidity is cross-chain, then security must be cross-chain too. And we wanted to build something that helps users avoid risky wallets, builders protect protocols proactively, and ecosystems move from reaction to prevention. And that's why we built Paratrace. So let us move on to our idea and our end-to-end product flow. So that's what we see our XCM activity across chains. We detect that, and the Paratrace monitoring layer actually detects that particular XCM transfer, and it actually profiles or records the transfer and analyzes its behavior. And there is a dynamic risk scoring based on its behavior and what are all the chains that it actually interacts with. And there is actually a risk threshold breach, uh, risk threshold, like if it is breached, like it has certain number. If it has been breached, it flags a wallet, and it exposes alerts to dashboard and also alerts to the protocol. If it doesn't exceed the risk threshold, it continues monitoring. And this is our actual idea. And for a end-to-end product flow, it's pretty much the same. As we can see that the XCM indexer captures the event, and the wallet history will be updated based on the event that has happened, and the risk is also evaluated based on the transfers and the wallet that it has interacted with, and also the chains that it has interacted with. And based on the dynamic risk scoring, if it is high, like above 75, and it actually flags and emits alert, and also it can be visualized through the dashboard. And there's a compliance protocol action which will be takes on the wallet which receives such a high risk score. And if there's no such high risk score, it just stores and keeps on watching. So let us move on to our Paratrace app. As you can see, this is our Paratrace application. As you can see, your cross-chain risk intelligence dashboard for Polkadot. uh, Let us go to the next. This is our navigation system. It's a wallet lookup for searching the wallets and the looking up for their profiles. There is the flag wallets which have a high risk score. We can also connect the polkadot.js extension, and this is for also doing that live XCM transfers. And these are all the metrics showing the transaction monitored wallets, flagged addresses, and average risk score across the network. And these are the risk trends, visual breakdowns of risk distribution and chain activity trends over our charts for getting the detailed data points. Okay, next is the recent activity of all the recent transactions just taking place. You may wonder, like, why are these in why are they in EVM addresses? But actually, I've actually used they are actually substrate addresses which has been converted into EVM format, because those are actually just stored in the Polkadot hub testnet. So let us move on to theme preference. We can also change the theme. So this theme change. Hope you like the UI, and we'll be able to see the wallets, and we'll go to any of the transactions, and the RPC URLs are fetching the data. So if we click on that, it will directly show up to the wallet lookup, and it will show the profile for this particular wallet. As you can see, the risk score is actually very low, and there is a chain interaction network for all the networks that it has interacted with, and you'll see the latest transaction history of this particular wallet. And if any score is actually high, it'll actually flag the wallet. As you can see, these are metrics for the risk analysis, and XCM diversity, network velocity, and flag proximity. You'll see the flag was here. As you can see, there's actually a score which I actually directly stored it in the Polkadot Hub testnet without using a real wallet. That is, it's just like a sample data which I added. It's not a mock data, but it's actually stored in the blockchain and it's retrieving from that particular blockchain. So let's do a live XCM transfer. Let's connect the wallet now. As you can see, it's connected to the polkadot.js extension. As you can see, this substrate address. We'll try sending to the same address, bridge hub. Maybe I'll just try sending to another address. I'll send this to one. Okay, this is the substrate address. We'll send around 0.5, 0.4. It's connected to a Western RPC wallet. So it's asking for my password. Sign the transaction. What's the password is on? Okay, just succeeded. As you can see, I can also view this in subscan. That particular block which has been initialized, it's unfinalized yet. And if we go to the dashboard, the XCM indexer is always listening. So as you can see, the total number of transactions is around 195. I think the XCM indexer is not loaded yet. As you can see, I can also view this in subscan. That particular block which has been initialized, it's unfinalized yet. And if we go to the dashboard, the XCM indexer is always listening. XCM indexer is always listening. So as you can see, the total number of transactions is around 195. I think the XCM indexer is not loaded yet. Wait, let us refresh the page. I guess it will be loaded now. As you can see, the number has increased. You can see that this particular wallet has made a transaction from the Western relay to the bridge hub to that particular destination address. Loaded now. As you can see, the number has increased. You can see that this particular wallet has made a transaction from the Western relay to the bridge hub to that particular destination address. Let us see. Click view transaction. It will be opening in Polkadot Hub testnet as it's the particular transaction hash where that uh, thing is stored. So when we go back to this, so when we actually see this, uh, I have actually finished the live demo. So the challenges that we faced are actually one key challenge that we faced was in the production deployment. We encountered build failures due to dependency passing issues in modern bundlers. So instead of patching around it or forking libraries, we built an automated patching solution, making deployment stable and reproducible. So that's what we implemented an automated post-install patching workflow to sanitize affected files before build time. So this actually happened while we using the Next.js 16 Turbo Pack and using the Polkadot.js wallet extension libraries. And the issue was legacy octal escape breaking production builds during production builds. So actually we cleared that particular thing, and the result was stable, repeatable deployments without forking upstream libraries, enabling reliable public access to Paratrace. So to conclude with, Paratrace helps shift the ecosystem from delayed detection to real-time prevention. In a world where interoperability is the default, trust infrastructure must also be interoperable. And that's what exactly Paratrace is building. And thank you all.